Hello everyone. Today our topic is layering of atmosphere or the structure of atmosphere. We will learn from the topic the composition or structure of the troposphere, stratosphere with special reference to ozonosphere, mesosphere, thermosphere, exosphere and magnetosphere. We already have come to know that atmosphere is like a spherical cell which envelop the earth. We can classify this atmosphere based on different subjects like chemical structure, thermal characteristics, etc. Here we have classified based on chemical structure, homosphere and heterosphere. And based on thermal characteristics, we have classified atmosphere into troposphere, stratosphere, mesosphere, thermosphere, exosphere, and magnetosphere. Now let's see what is homosphere and what is heterosphere. We know that from the Earth's surface, if we consider this one as 0 kilometer or Earth's surface, our atmosphere is extended up to almost 10,000 kilometers outward. Homosphere is extended up to 90 kilometers from the Earth's surface. It is called homosphere because the composition in this layer is homogeneous in nature. And this homosphere is extended up to 90 kilometers, or we can say up to the top of the mesosphere. So this portion is homosphere. This portion is homosphere. And this homosphere is classified based on temperature into troposphere, stratosphere, and mesosphere in these sublayers. And each sublayers are separated from each other by a very shallow transitional zone. Like troposphere is separated from stratosphere by tropopause. Stratosphere is separated from mesosphere by stratopause. So this is homosphere. Now let's see the heterosphere. This heterosphere is extended from 90 kilometer up to 10,000 kilometer. Here the composition are not homogeneous. We see the molecule nitrogen is heavier and that's why it exists in the lower part. And the atomic hydrogen is lighter and that's why it exists in the outermost part. This heterosphere can be classified based on their element, like molecular nitrogen layer, then atomic oxygen layer, then helium layer, and atomic hydrogen layer. Atomic hydrogen layer, it is the outermost part. It is extended from 3,500 kilometer to 10,000 kilometer. Helium layer, it is extended from 1,100 kilometer to up to 3,500 kilometer. And obviously in that layer the helium gas, presence of helium gas is maximum. And in atomic oxygen layer, here the presence of oxygen, atomic oxygen is maximum. And molecular nitrogen layer, here the nitrogen molecule prevail. This one, nitrogen layer, here the nitrogen molecule presence is maximum. Now let's see the layering of the atmosphere based on thermal characteristics. Generally, we can classify into these categories: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. And beyond that, we say magnetosphere. Okay. Troposphere is the lowest part of the atmosphere in which we live. The term troposphere and stratosphere, first suggested by Terence de Bort, T. de Bort, B-O-R-T. Troposphere literally means the region of mixing. The term tropo is derived from Greek word tropos, which means turbulence or mixing. So troposphere means the region of mixing. Average elevation of this troposphere is about 16 km over the equatorial region and 8 km over the polar region. And if we see, the temperature in this layer gradually decreases with elevation, which is about 6.5 degrees Celsius per kilometer, or 3.5 degree Fahrenheit per 1000 feet. 3.5 degree Fahrenheit per 1000 feet elevation, which is known as normal lapse rate of temperature. This troposphere is also called as convective region, because all kind of convective activities that take place in this layer. Above this troposphere, no circulation or convective activity is found, and most of the, or we can say, all kind of cloud, all kind of thunderstorm, cyclone, etc., that form in this troposphere. Another thing is that in the troposphere we found aerosol, maximum presence of aerosol and water vapor. In fact, uh, water vapor is only confined in the troposphere. Above tropopause, we know that tropopause is the boundary line or the transitional zone between the troposphere and stratosphere. So above troposphere, there is no water vapor presence. The term tropopause was first used by Napier Shaw. We can classify troposphere into two categories. That is, one is frictional layer, another one is convective layer. Frictional layer, it is confined within 3 km from the Earth's surface, and beyond that, up to tropopause, this is known as convective layer. Now let's see the characteristics of tropopause. Already we have known that tropopause is a transitional zone between troposphere and stratosphere. So this portion we can say is tropopause. Average thickness of this tropopause is about 1.5 km. And it is called tropopause because tropo means we have known that turbulence, and pause, that means stop. So all kind of turbulence stop in this layer. That's why it is called tropopause. And another thing is that tropopause is the upper limit or the last limit of the presence of water vapor. And the tropopause elevation changes over season as well as latitude. It has been found that near 45-degree latitude in both hemispheres, in the month of January, the average elevation of tropopause is around 12.5 km. While in the month of, that is in January, while in the month of June, this elevation increased up to 15 km from the Earth's surface. As well as it has been found that the temperature of tropopause also changes over latitude. it has been found that near the equatorial region, the average temperature is around minus 70 degrees Celsius. And near the polar region, the temperature is about minus, if it is equatorial, it is polar region, about minus 50 to 60 degrees Celsius. It happens because we have already come to know that the elevation of troposphere or the height of troposphere, that is maximum in equatorial region, that is 16 kilometers from Earth's surface, and in that polar region it is 8 kilometers from the Earth's surface. Okay, now let's see the second layer of the atmosphere from the Earth's surface, which is known as stratosphere. The stratosphere begins at the tropopause, which forms its lower boundary, and it is extended up to the stratopause. From tropopause up to stratopause, that stratosphere is extended. Now let's see the other features of that stratosphere. It is said that stratosphere is extended upward from the tropopause to about 50 kilometers, and it accounts for about 10% of the total atmospheric mass. I would suggest to notice that graph, this graph, which is showing the temperature with altitude as well as the pressure with altitude. If we see the graph, initially up to the tropopause, the graph gradually decreases, and at tropopause the temperature reaches up to minus 50 to minus 60 degrees Celsius. And after tropopause, the temperature started to increase gradually, and at stratopause it reaches up to 0 degrees Celsius. It happens because of the presence of ozone in that region, because we know that in stratosphere maximum concentration of ozone is found. Ozone density reaches at its peak at approximately 22 kilometer altitude. Maximum ozone concentration is found here. The sphere is relatively stable and relatively dry, and very little amount of vertical motion is found in that layer, and for that reason aeroplane and jet plane etc. flies through this layer. Generally no cloud is found in this stratosphere, but sometimes a cirrus cloud, which is also known as mother of pearl clouds, occasionally form in the lower stratosphere.